Hello everyone, welcome to my channel. This is Dr. Fan. In this channel, I will solve practice problems to help you better understand the physics concept and the formulas. For the students who are taking AP Physics 1, I hope I can help you to get a 5. Today, we are going to solve one question covering all the key concepts in 1D kinematics. Okay, let's get into it. So the question says, a ball moved towards the east with a velocity of 3 meters per second. A stable wind blowing to the west gave the ball an acceleration of 1 meter per second square in the first 2 seconds and an acceleration of 3 meters per second square for another 4 seconds. And the first part of the question asks, what is the total displacement of the ball in these 6 seconds? Alright, whenever we are working on a physics questions, we have to evaluate the situation. So this question is clearly a kinematics question. And let's see what we know. We know this motion has actually 2 segments. In the first segment, the acceleration is minus 1 meter per second square because the acceleration is going to the west. And we choose going to the east as my positive direction. And the time is 2 seconds. And we do know the initial velocity for the first segment, V0, is 3 meters per second. 3 meters per second to the east, which is my positive. And for the second segment, I know the acceleration is minus 3 meters per second square, and I know the time is 4 seconds. So in order to find the total displacement of the ball, I need to find the displacement for each segment of the motion. Let's first look at the first segment. We know the initial velocity, we know the acceleration, and we know the time. So we can use this kinematic equation. Dot x1 equals to v0 t1 plus half a1 t1 squared. If we plug into all the values, this is what we have. 3 meters per second times the time, which is 2 seconds, plus half minus 1 meter per second squared times 2 seconds squared. So after calculation, we got 4 meters. So that means in the first 2 seconds, the displacement is 4 meters. So what about the second segment? We know the acceleration and we know the time, but we do not know the initial velocity for the second segment of the motion. But we do know right after 2 seconds, you start your second segment of motion. That means the final velocity, or you can say the velocity after 2 seconds, is the initial velocity for the second segment of motion. So what is that velocity after first 2 seconds? If we use this kinematic equation, v1 equals to v0 plus at, we can find out that velocity. If we plug into all the values, 3 meters per second plus minus 1 meter per second squared times 2 seconds, you got 1 meter per second. That means after 2 seconds, your velocity is 1 meter per second. So now for the second segment, we know the initial velocity, we know the acceleration, we know the time. If we plug all this into this equation, delta x t2 equals v1 t2 plus half a2 t2 squared. So substitute all these values, we got 1 meter per second times 4 seconds. That's the time for the second motion, plus half minus 3 meters per second squared times 4 seconds squared. And if you do the math, you got minus 20 meters. That means for the second segment, your displacement is minus 20 meters. So your total displacement would be 4 meters plus minus 20 meters. So your total displacement would be minus 16 meters. That is the answer for the first part of the question. Okay? Sounds good, right? Alright, let's look at the second part of the question. So now it's asking what is the distance the ball traveled in these 6 seconds. We know distance is different than displacement, right? We all know that. Let's look at how to find out the distance traveled. So we know initially the ball has a 3 meter per second velocity and going to the east. Then after 2 seconds, it travels 4 meter. The velocity becomes 1 meter per second. We solved that in the first part, right? And in the second segment, we know this ball actually travels what? Minus 20 meter, right? So some student might say my distance, right, actually equals to 4 meter plus 20 meter. So the distance is actually 24 meter, which is actually not correct. Why? Because after 2 seconds, you still have a velocity of 1 meter per second. So the ball will continue to move to the east until it's going to turn back. So the ball actually is going to travel until it turns, then go back, and then travel to the west. So this blue distance is actually ignored in this calculation. So the total distance needs to include this blue distance. So how we are going to calculate this blue distance? We know whenever the ball turns, its velocity becomes 0. In other words, the velocity is 0 here. So then we can actually find out this displacement right here, delta x. So how to find out this displacement? We know the velocity here is 1 meter per second. And we know the velocity here is 0 meter per second. And we know the acceleration from here to here is minus 3 meter per second squared. So we can use this kinematic equation. V squared equals V1 squared plus 2A2 times delta x. So if we substitute all the values, we got 0 meter per second squared equals to 1 meter per second squared plus 2 times minus 3 meter per second squared times delta x. So if you do the math, the delta x is it's positive. It's 1/6 meter. So that means from here to here, the displacement is 1/6 meter. So from here to here, the displacement is also 1/6 meter. So the total distance you should get is 4 meter, which is the distance traveled here, plus 2 times 1/6 meter, which is the distance traveled here, plus 20 meter. So your total displacement would be, your total distance would be 24 and a third meter. So that's the distance the ball traveled. Here I want to use this example to show you that the distance is different from displacement. And in order to calculate the distance, you need to calculate how the motion covers along the whole path. Alright, now let's look at the last part of this question. It's asking what's the average velocity of the ball in these 6 seconds. Okay, some students might think this would be very tricky, but it's actually very straightforward because the average velocity equals to delta x over delta t. It does not matter how many segment motion you have. It only cares about your final position and your initial position, then divided by time. We already know that the displacement in these 6 seconds is minus 16 meter. And also we know the time is 6 seconds. So that means the average velocity is minus 8/3 meter per second. So that means this ball on average is actually traveling to the west because you see a negative sign here. So the average velocity is minus 8/3 meter per second. You see, in only one question, we covered all the key concepts in 1D kinematics. I hope this question helped you guys to better understand 1D kinematics. I'm gonna leave one question for you guys to solve. Can you plot the position and the velocity versus time chart for this motion? Thank you for your attention. I will see you next time.